are you today?
I'm doing really well. Thanks so much for having me here.
Oh, I'm so excited to have you. Not every day you've got a real prodigy on. I've been looking into your background, and also we spoke earlier. You must have been an interesting student to have in school.
I'm sure I was, to say the least. I think different teachers responded to it differently, and some I'm still wonderful friends with all these years later, and some I'm not.
Yeah, that makes a lot of sense. I mean, in all seriousness, it's sort of a blessing and a curse, right? Because no one really begs for being different. Even in a positive way, arguably, right?
No, I mean it was definitely we can argue back and forth on whether or not it's a positive way, but certainly given my state, traditional education was always a bit tough, but I think the positive that it really brought across was that it gave me a really clear sense of how differently different people can learn. And, granted, it meant that a lot of high school was maybe not perfectly fit to my style, but it meant that when I found a school that really sort of spoke to me for college, it was that much clearer to me how different it was from a traditional education. So.
Talk about this, so I may be in deep water here, but you went to North Hollywood Highly Gifted High School. I'm guessing it was different from 90210 high school experience, which I recall
Oh
from
gosh, yeah.
watching old
Oh
TV
wow.
shows.
Yeah, yes, very different. Probably the first thing to clarify for people that don't know about LA is North Hollywood. Probably, when people think Hollywood, people sometimes think a very glitzy kind of fancy place. People from LA, I never have to explain this to, because North Hollywood is very much not that. North Hollywood is a lot more famous for its gang violence than for anything upscale. Uh, no, I mean it was a strange high school, to be sure. It was a very interesting. I mean, I'm extremely thankful for it. Right, I think the Highly Gifted Magnet. It's a really, really great program. It's been under a bit of siege within LAUSD in recent years. My graduating class, actually, if you can believe it or not, at a public school was 42 students. Uh, so it was. I don't know. I always just considered it special ed, frankly. But we did have more than our fair share of academic awards.
But Slater, then you went on to Olin College, which is in my neighborhood here in Wellesley, and that's another very special school in the sense that they follow a quite different curriculum. How was that experience for you?
It was wonderful. I think the best way that I could sum it up is when I was out looking at colleges, I had the implicit assumption that no matter where I went, I would not go to class very often. I would show up for tests, and hopefully, I would be able to get good grades. And so that was actually something that I was actively kind of screening for in the schools, right? Like, do I have to show up to every class? Um, when I showed up at Olin, though, they were the first school that ever convinced me that I had it wrong. And for those of you that aren't aware, which is probably pretty much everyone, because Olin's very small and very new. Olin is totally engineering education, and it's entirely project based. And what that meant is that going to class wasn't about hearing a kind of half-baked lecture that I was going to go and have to reread the notes after class anyway, right? It was much more about having active help on projects that you were working on, right? These were actual applications of the theory that you had learned earlier in the week. The thing that I just really, really loved is that there's no hiding. Right. I had gotten pretty good at taking tests over the years, and I always felt bad that, especially if it's a multiple choice test, pure strategy can just do so much for a test like that. But when it's like they always say about engineers, right? There's no partial credit if the bridge falls down. Even though, like at Olin, they probably would give you partial credit for trying something so ambitious. But the idea is when you actually have to make something work, you really have to push yourself to a much deeper level than you would otherwise. And I think a lot of schools are kind of afraid to put that much pressure on students. Not for terrible reasons either, but for me it was really, really effective. I actually withdrew my application to every other school after I visited Olin for the first time. So it was the only school I applied to for college.
I wanted to spend a little time on your background because we'll very shortly move on to various parts of this AI picture. But I do think that your background, it does spell. It's interesting to just consider. I know you're also very much into Chinese fantasy fiction, where immortal heroes
Yep.
are battling, and I'm wondering that kind of fictional universe. I mean, was that sort of an escape that just provides a very rich environment, sort of quite different from the everyday that you were faced with? I'm not trying to psychologize you, but there's something kind of cool about just jumping into fiction really, really deeply. Tell us about that.
No, that's fair. I mean, I will say, have you ever heard The Hero with a Thousand Faces?
Hmm.
So this is a book by Joseph Campbell, and it's one of the first books where he kind of outlines his hero journey. And there's a quote that he has pretty early on in the book that the first time I read it, I thought it was the most grandiose, absurd thing that I ever heard. And as time went on, I've kind of learned to appreciate more and more like the gravity of these words. So it's the story is the portal through which the boundless energy of the cosmos pours into human society, very roughly. And it's again, like just on the face, and I'm probably butchering the quote a bit, right? You can look it up. It's not too far away from that. It just sounds so grandiose, right? How could this possibly be true? But what he goes on to describe, and what I think people kind of rail against this unconsciously, but actually embracing it has been really effective for me, which is that fiction allows you to kind of go outside of yourself to solve problems that you're too close to as an individual, right? And it was something that I had never really considered, or if I ever thought about fiction like that, that was me not being strong enough to get over that hump. But what I had never thought about it as is fiction is almost this force multiplier for your efforts, where by getting outside of your mind a little bit, you can get a new perspective on a problem. And I just thought that was really, really powerful. I happened to find, Xianxia, which is, these Chinese immortal fantasy books, really compelling for a couple of reasons. But I think one of the ones that it's most strange from a Western perspective, because these books are really heavily intertwined with religion. And one of the things that is near universal, actually, is that the line between like humanity and divinity is extremely blurry and porous, right? And it's kind of this assumption, right, is that if you're good enough at being a person, at some point you gain all these kind of special abilities, which like I think it's kind of a fun idea, but I think just that blurry line is such an alien concept from, I think, like a traditional like Abrahamic background. So I really appreciate the take.
Well, look, you provided me with a nice segue because whether there is a massive schism between humans and the divine, right? It's arguably a little up for grabs in at least some people's fear about AI. So let's fast forward to present day. You're with the company you founded, Indico. You've just raised $22 million, and you're involved in what you guys call intelligent process automation, which I'm taking to be a version of what people have called RPA, or robotic process automation, which is an interesting field in and of itself. But you have a sort of little take on this, and you're definitely involved in multimodal systems. And I wanted to get us into this discussion about what's really going on in technology these
Absolutely.
days. Wanted you to maybe start us off a little bit with kind of getting into this dichotomy between supervised and unsupervised learning, and sort of the data spectrum that we are faced with these days. Because it's not just
Definitely.
algorithms sitting on an academic shelf anymore. I mean, this is real world data with real world consequences, and just bring us into this
Absolutely.
universe.
Yeah, and I think I really love the lead in with RPA, because I think that's also an interesting lens that kind of is brought to this whole problem. And again, for folks that I think RPA, the bounds around it are kind of fuzzy, like in a lot of cases, and people might have different definitions. But traditionally, I think of this as robotic process automation, and that's to say you're automating robotic processes again, which is pretty reasonable, but people often don't break it up that way. And that's to say processes that can be really easily broken down into, pick this up, put this down, copy a value from here, paste it there. And what RPA has really exposed is that, there are a huge number of use cases that fit really well into that mentality, and it's a perfect fit. And what they tried to do at first, actually, was make AI fit into that kind of a bubble, right? That kind of a construction. And that's where you get a lot of these black box conceptions of AI, right? Which is it's a closed off API, and it's got an input and it's got an output, and I can't change it, and I have no idea what's going on inside of it. And I think that it's made to fit into that RPA mentality, right? It's kind of an activity like any other. You can copy something, you can paste something, you can extract the values of an invoice. But I think what's really interesting, and this is both true about intelligent process automation and I think AI more broadly, is that it turns out that these very what I'd call myopic problem framings, I think we're really starting to run into the inherent limits with those framings. And I think on the AI side, you see this everything from a basic, binary classification of sentiment, but you see it reflected in RPA as well, right? This idea that you've got these very neat bundled outputs of every single model that you create. And certainly, those are powerful abstractions, right? I mean, everything is classification and regression, like that's a powerful abstraction that's gotten us a very, very long way in the ML space. But I actually think that it's kind of getting to the end of its life, right? And I think that these simple problem framings, are turning really into shackles more than anything that's going to push us forward. And we can dig further into kind of multimodal and the data spectrum, because I think those are some really interesting talk points here. But maybe before we double click on those, I think one of the really broad, interesting kind of shifts in this space is that. Did I mention at all the clever Hans effect to you when we talked earlier?
No.
Okay, so it's a kind of nascent term for what I'll dub incredible intelligence and stunning ignorance in these ML models, right? So, in AI, we've got this paradox where, every problem that we can crisply construct and measure the output on, it looks like these models are performing as well as humans. At the same time, we shift anything about it just slightly. It's almost a child's play, right? To get these same models to exhibit really stunning levels of ignorance. And I didn't come up with this term. Someone else has kind of dubbed this the clever Hans effect. And have you ever heard of clever Hans?
I haven't myself. So explain it to our listeners.
Yeah, I think it's an American story, actually. And it's from kind of an old... and that's to say, I'm not 100% sure where it has come from, but it was a real horse in the 1800s. And the idea is that this horse could do math. And it was in one of these old kind of traveling medicine shows where people would come to see the horse that could do math. And the way it would work is they would have this chalkboard set up, and they would write down, a very basic kind of addition, subtraction, multiplication kind of problem. And the horse would then stamp its hoof. Until it got to the right answer, and somehow it was always right.
This is ringing a bell now. Yeah.
And
it's a funny.
It turns out,
funny situation.
Absolutely, and so they did a lot of testing, just to figure out, okay, how on earth is this happening? And no one was really aware. Everyone thought this was almost legitimate. But what it turns out is that the only thing that the horse had to do actually was read its handler. And so because of the way they were measuring it, right, where it was stamping its foot until it had to stop, it was just reading the handler to see when the handler was tense. And then, it stamp. It finally hit the right number. It looked for that relief in the handler's body, again, completely unconscious, and gets the right answer every single time. And the argument goes, there's a close analogy for AI where often we can get the right answer through the wrong path, that then begs this question of, okay, how do we actually force this AI? How do we actively encourage it to follow the right path? So,
look, I'm interested. It's fascinating. The clever Hans idea is fascinating, and certainly, in today's AI, I find there is a lot of sort of both. There is a lot of the clear hype, and then there's a lot of the enormous skepticism that, because there is hype, there is nothing here. And, there are people saying, this is just math, like you were onto this, like this is just regression. and you could sort of be impressed or not by regression, but at the end of the day, is there really nothing behind here? Is this just sort of some pure statistics with some extra bells and whistles on it? And where's the real mass? Where's the real magic in here? And if there is magic, some people would say arguably that magic is a black box, and we can't have that, right? And there's legitimate
I know,
debate around
absolutely.
that, because whether it is magic or not, if it is a black box, and if it does turn bad or biased, that is arguably more and more of a problem. So what do you have to
Absolutely.
say for that? And also, as we get into more kind of multimodal data sets as well, where you're taking in an
Yeah.
enormous array of data. You're not just comparing apples and apples that have been classified as various colors, just to simplify it here, but we're taking in
Mhm.
pictures. You're taking in things that are analyzed in various ways, and then you want it then combined to do pretty amazing
Mhm.
things. I mean, it wouldn't take much of a critical mind to sort of think this, is going to have to fall into some sort of system that we can understand. Otherwise, where is this taking us?
Absolutely. And I agree 100% with everything you've said. And so here, my first answer is like I don't believe in magic, right? Very much, AI, and I deal with some pretty sophisticated modern deep learning techniques in the grand scheme of things. And so, let me just say, right out, there is absolutely no magic here, right? It is just statistics at the end of the day. Now, granted, I don't want that to detract from the real impact of these new techniques, right? My view very much is that all academic inquiry is almost out of necessity incremental, right? But that making real incremental improvement is incredibly difficult to do. And when someone has made a real incremental improvement, and that's what I would say, modern deep learning techniques are, right? It was kind of this real, very significant increment made in the machine learning space, right? I mean, it didn't recreate it. I mean, these techniques existed, but it was a critical mass of almost tips and tricks that we accumulated to actually get the damn things to work, right? And so I find it really, really difficult. And again, as a deep learning guy myself, I really rankle almost at this pitch that so many people have, which is that deep learning is this panacea and it's going to walk your dog and clean your car, right? I very much don't believe in that. So what I would say is I also think that explainability. I think explainability is it's a complicated term, right? I think different people mean very, very different things by explainability. I think that the most important aspect, though, to recognize about AI is that it is only as useful as our control interface to it is, right? To that point, right? If it's magic, if we can't control it, if we can't push it left or right or correct it, it is not a useful thing. And I think that this is where there's actually, I think, an analogy that people have for AI kind of implicitly that's it's simplistic, it's maybe even harmful, which is sort of this notion of AI as kind of an autonomous, conscious thing with its own drives and desires, right? They'll frame things. Does the AI understand? Right. And that's just, it's not how it works, right? At the end of the day, it is a set of tools that we have to deploy in very, very specific ways. And where I think this touches really interestingly on multimodal learning, and where I also think that we're kind of pushing on some of the boundaries of current problem framings, is that we are officially giving our modeling too simplistic a task, right? For a long time, we weren't able to solve these simplistic tasks. We weren't able to solve these really niche point tasks, but now we can. Unfortunately, we're now looking at these very niche point tasks as symbols of broader intelligence, and there's no accuracy level you can hit on sentiment analysis that is a significant advancement in this space, right? Like I don't care if it is 100%. Like there is no 100%. We have to evolve beyond this simple construction of sentiment analysis, right? Or these simple classification constructions.
So I want to dig a little deeper on some of these things in a second, but first, another thing that sort of I guess, puzzling in this debate is, and I think Indico is, I guess, an example of it too. How is it, if it isn't magic, in a sense, a magic in sort of like colloquial sense, that a small-ish startup, and you as an example, there are other startups obviously in AI, can manage to beat these massive juggernauts, whether it's famous IBM, famous because it's easy to beat on IBM, because they're so big and have been around. So it's like a fun thing to do.
Yeah.
But in all seriousness, how is this even possible that you can? I mean, is it the more clever use of existing tools? Is it some clever access to data that corporations or otherwise have given to you? Or is it that there are still some tricks in the trade that do require a little bit of feel for the game, or something that you just have to stumble upon that isn't just building block upon building block? Because I would sort of like assume, and again, I'm embellishing it a little bit, but here's IBM. They've been doing all of this. They have thousands of people engaged in this activity. Why is it that they can't build rock upon rock and then just really just blow you guys out of the ballpark any day they want?
It's an absolutely great question. And, I think I'm going to start by saying that, yes, Indico has done this, but to your point, we're far from the only ones, right? I mean, you look at Clarify, right? I mean, you look at Alien, right? And everywhere you look, kind of the world is dotted with these really impressive companies doing real significant work in the ML space. And to your point, as an outsider looking at this, you're like, okay, Google has invested billions of dollars into an industry research lab. And how is it possible that, Joe Schmo in his bedroom, and some of these people are literally Joe Schmo in their bedroom, right? I mean, that's how we started in this space. We were Joe Schmo in a dorm room, can actually contribute to this space. And I think that the key is that people, because they don't spend a lot of time in academia, they misunderstand the nature of academic exploration. Right. I think people often have this notion. Sometimes I joke. It's the old man jumping out of a bathtub, shouting "Eureka!" Right. That there's some fixed list of problems, right, and then you're going to like check them off, and then somehow everything, right? But especially in AI, especially in a space that is very early on, actually, research does not work like that. So basically, every paper that you put out is going to ask two more questions. Right? And you've got this interesting thing where sort of the frontier of research is expanding outward broadly in kind of all directions. And that means the surface area that you can kind of devote yourself to make real significant improvements is also increasing. And I think that's something that a lot of people don't realize. I actually often like to tell companies there is no better time for a startup that is trying to make a real technical advantage to start their ML journey than today. And I will also say that the other thing that allows these small companies to have so much success relative to investment is that the problem is fundamentally a system level problem, right? If you ask what are, these massive companies really, really good at, is where it is one block ahead of the other and, very linear path to improvement, they can execute like crazy on that. And I don't care whether it's Google or IBM or Microsoft or Amazon, they are going to win. Right, if I had to compete on the economics of marginal S3 capacity, not a chance, right? But because so much of AI today is not just about model infrastructure, right? It's about how are you going to supervise it, right? How are you going to actually get the infrastructure working behind the scenes? And the truth, the ugly truth is, frankly, that academics hate to work on these problems. And academics are so honored today that you can't get an academic to work on something that they don't want to work on. And so it means that there's kind of this very big blind spot where they're always going to have the best architectures. But even within their own organizations, believe it or not, it's very easy for a small company like ours to look at research that their labs are publishing. And because of their internal processes, we may have it in production before they do, maybe even months or years before they do. Which, again, I think it really goes to say a lot more about the space than anything.
It was so interesting to me, unless I misunderstand you, but you're characterizing big tech companies in the same vein as academic labs, in the sense that you're saying they have this, they're basically burdened with the same kinds of problems because of their size and their interest in the generic nature of the problem that anybody really from the outside who can pick up the pieces and execute faster and more creatively, I guess, has a shot right now at this very
Absolutely.
moment. Perhaps though it is a temporary advantage, right?
I think 100%. In fact, I'd kind of go a step further and just say that, and I also will say, I think this is unique to AI as a space. Most academic spaces, I don't think work like this, but there is so much open publishing and the space moves so quickly that, the era of trying to have some proprietary advantage that you guard, it's gone, right? Because the duration of a state of the art algorithm today is months, right? Again, companies, lifetimes are measured in years and decades. So, either if you think you've got a proprietary advantage, either you're mistaken and you're missing some research that someone else out there is doing, or you have 6 months to live.
And then Slater, what might be the reason that so many of these startups are kind of, I guess, allowed to exist for quite a long time? Is that because this only serves the big tech ecosystem to have all these startups out there, and it's not really a threat because you could sort of pick them off the ground anytime you want, and it's just you need all that variety to make this sort of even incremental progress that I guess many of us are interested in, and and some of us fear, right? This is sort of a progress that would take us somewhere really, which we'll get to in a second, somewhere really far beyond where we are right now, which I guess is kind of a little bit our discussion as well. Where are we at this moment in AI, and are we heading into a winter, a summer, a spring, or whatever season you might, you might fancy?
Yeah. No, I mean, it's a great question. I mean, and I think honestly, your initial take is pretty spot on. I think that for all of the progress that has been made, and this is something that I don't know, either I've gotten more cynical or realistic over the years, but I used to think in individual years. Now I think in terms of decades, right? So the adoption is certainly going very, very well, but we're still in sort of the first decade of adoption of most of these techniques. And I think it is exactly that, right? Is I think that, Google and anyone that really understands this space realizes that there is too much ground to cover for individuals, right? And I think certainly their plan is they're just going to look at all of these seeds and, they're going to see what pops up. I think one thing that's also, though, really interesting is when you look at a lot of the ecosystem players like NVIDIA, and NVIDIA obviously is. Do you know that NVIDIA has a 50% higher market cap than Intel today? I was shocked. I did not believe that.
It's an extremely interesting company that would take an entire podcast to explore for sure.
No, so they have one technique in particular, just where they invest heavily into the ecosystem, and they don't want anyone to be acquired, and they just want to sell GPUs. So,
well, in fact, I've been looking at their startup lab. Basically, I can't remember what it's called right now, but it's gotten quite some attention because they literally have this ecosystem approach to startups. As long as you are interested in broadly working in the direction that, or not even, I guess, using their platform, but everybody at some point will be using their platform, right? So they just
absolutely
want the 1,000 flowers to bloom, essentially.
And NVIDIA has really done a lot for the community. I think there's a couple of huge players that I think have, without them, this AI renaissance would not have happened. And NVIDIA is absolutely one of them. In fact, NVIDIA is probably the only one that managed to successfully capitalize on their position. I think Kaggle, for instance, is another, but, NVIDIA actually made an incredibly successful business and continues to do so, whereas Kaggle, they did a comparable amount of good in just educating the world data scientists out there, but, obviously a very different commercial outcome.
Well, I mean, they're an interesting counter sort of to NVIDIA, though. One sort of like more hardware based and one people based, I guess, believing in networks of clever people. I wanted to take us a little bit towards sort of the future, because a lot of these AI debates, they either sort of stop at like status quo, where you can sort of discuss what's possible now and what's going on right now. I wanted to kind of bring us a little bit out of that picture, but not only from this whole like visionary, like crazy, the world's so different. But if you just look at you said you think in decades. Let's sort of roll up some decades here. If you look at the next
Yeah.
decade, I don't know. My first take would be, it would be further in this multimodal direction. So there's going to be a lot of
Hmm.
blended techniques. We're going to have to spend more time than we really wanted
Absolutely.
to testing them and verifying them, and there'll be an enormous governmental regulatory backlash, obviously, because these things are getting serious. That much is very
Hmm.
certain. What else are we to expect this decade?
Yeah, so I think that there's really really deep potential in the multimodal space, and I think maybe to paint the picture, because again, I think you and I have talked about this, but it maybe maybe not every listener has this idea that traditional machine learning works within a particular modality, text or image or audio, and we're starting to see this today with some of the papers out of OpenAI, but I think again very much in their infancy, where you actually blend together these different modalities. And I think it happens in two directions, which is kind of interesting. So you have one direction, which is a clip out of OpenAI was sort of the recent hot thing here, where you have one model that can understand both text and image, right? That can caption images, that you can type in text and it'll generate some image as a result, and it's very very interesting to have that kind of central reasoning chamber, if you will. But I also think the inverse of that problem is really, really interesting, because what they're not doing, for instance, they don't have blended image and text that they're trying to do inference on, right? And I think that there's another kind of very interesting spur of this research that's coming out now. And I think people have, it's pretty hotly debated how interesting this field of study will eventually be, but neurosymbolic methods, which is a little bit this idea of how do we take this really fuzzy, rich, unstructured understanding that we've got with today's deep learning techniques and maybe fuse them with some of those older symbolic techniques and find if there's kind of a happy middle path where we can have our cake and eat it too. And I think neurosymbolic techniques are probably one of the areas in AI where I'm most ambivalent, right? And not in the like I don't care one way or the other. It's that I've got really conflicting ideas about whether it's going to be really really successful or not. But I think again, it's one more area of these multimodal techniques where we're starting to see some really really interesting research. And I think when we kind of cast this forward and start thinking about a lot of these kind of more detailed inference problems, when we think about doing video inference, when we think about combining text systems with systems that reason over time, these are all things that today you have to handle in kind of a very choppy, inconsistent way. And I think, the techniques to handle these in more comprehensive and effective ways, they're burgeoning now, and I think it's a really really good time to be advancing them, because I think again just the surface area of the space is so large.
Well, does this mean that sort of pure play neural nets have kind of run out of steam? And is that why they're seeking more inspiration back in the symbolic domain? And by the way, symbolic is sort of hard to understand for an outsider, actually, probably even for an insider. What exactly are the symbols that we're talking about? Why don't you line that up a little bit and then I'll ask my question.
Definitely, yeah. So, and it is reasonably tough because the notion of symbol is just it's so vague. But it dates back to kind of a very old way of thinking about human cognition, almost, right? And I'm sorry, I don't mean old in a derogatory way. I just mean like they came up with this in the 40s or the 50s, which is this notion that we are symbol machines, and so it's almost language, for instance, like each word I use, that is a symbol. The idea being that I have symbols inside my mind that I kind of explicitly am manipulating to come up with thoughts. Um, and for a long time, and I think part of this is just because it was academics creating theory, they're just like, this is how the brain works. Like everything is super explicit, right? We just have to figure out what each one of these symbols is, and then it'll be perfect. And they tried for a long time to do this, like decades and decades and decades. And I think thankfully we've recognized that humans aren't quite so cut and dry. Like you cannot mimic human reasoning without some implicit sort of surrender to the fuzziness of the problem. But again, it's one of these really interesting places of tension where we can, recognize and show explicitly, okay, there is fuzziness in this problem. But at the same time, it's not enough to just sort of hand wave and say, oh, it's fuzzy, so we can't understand it. And I think that's one of the really, fierce growing tensions as we try more and more to mimic humans. We realize that humans are a lot messier than we thought, and we're not very consistent.
I love that phrase that you had, that it requires surrendering to the implicit fuzziness of the problem, and I guess the fuzziness of the human being, which is interesting to me. And it's always been a thing that I've been struggling with when it comes to understanding any kind of cognition research, which I've also been involved with for some years. And it is this assumption that at any given moment when you are looking at this, you sort of think, well, we have a model of the brain and this is more or less how it works. Usually you start with the model of the brain, but if it's not the brain, you start with a model of behavior or something of that sort. But everybody who's involved in this business has the problem that they are stuck with wherever academia is at any given moment of time.
Yeah.
Right? And who is to say that we're any closer now, or like how much closer are we than we were 10 years ago, 30 years ago, when it comes to either understanding the brain or behavior or any of those things? Arguably, science moves somewhat forward, but if you're making too explicit reference to some academic paper or paradigm, and then you're saying, well, this is how reality looks, and that's why we're going to design a system to mirror that reality. I mean, you're arguably in trouble wherever in history you find yourself.
Absolutely. And I think it's one of the things, I think the most explicit place I can draw it to, right, is this notion of biological inspiration and neural nets, and our, neural nets in software are the same as neural nets in wetware, if you will. And you really did hit the nail on the head with the most important point, right? Which is arguably, I think we understand more about how the brain works now than we did 50 years ago. Like that, yes. We still don't understand how the brain works, though, right? It's kind of, we're chipping away at this absolutely massive, massive kind of area of research, and we don't even have a clear sense of how big it is, right? And so it's like, yes, we've chipped away, but, can I say whether we're 1% closer or 80% closer or 1,000% closer? No, I have no idea. And I think that, I don't know, I'm a little bit of two minds here, because I think that there are two modalities of people. I think there are people that really love the idea that neural nets and software are based off the brain and are going to try to like cram the two together at like every possible juncture, even argue that the two like mirror off of each other. And there's just no support for that, right? I mean, it's like we came up with the word neural network when we built neural networks a different way, and we thought the brain worked a different way, and the two have just like strictly diverged for the past 40 years. And there's not, you really have to strain to see any shadows of one and the other. But, on the flip side, there are some really interesting areas of exploration there, right? I think Yoshua Bengio is notable for this, in that he really wants, kind of the neuroscientists and the ML people to play nicer together. There's a lot of cranks that make it a little bit difficult, but he's been very, very good at actually finding good ideas in biology and, translating them over to the ML world in a way that, again, has a real understanding of both sides. So I really do hope to see more of it, if for no other reason than, I think we are a bit at the end of our current paradigm of thinking. And it's clear that we've got places to go next, but we're not sure which is sort of the right one. And so I kind of am like, we need as much inspiration as we can get.
But it is an interesting moment, though, for the reason that if it is going to be a winter or a fall or whatever season, right? Famously, AI has all these winters. It's not going to be a winter in the sense that we have accomplished nothing, right? Because and you're proof of that within Indico, because you guys are ingesting valuable data and you're making inferences and you are, relevant to companies today. So that's not going to go away unless we sort of start to say, well, we've been so wrong that these assumptions are like creating that, cars are crashing, towers are falling down, right? That would be a problem, and we would literally go into a winter. So, I hold that open as like point, a faint possibility. But if that doesn't happen,
but they've been in production for a long
Right.
time, right? It's like there's been really, really detailed testing. And, again, that's not to say that there's never going to be an issue, but no, I think that, the chance of that, it's vanishingly small
Right.
outside
So, I
chance.
mean, it may be a winter in the sense that it's going to take another few decades before we make the next big leap. How probable is that? So, fast forward 20 years, 30 years, and once you start thinking in decades, it's hard to kind of
Yeah.
like pin it down. But if you flash forward a couple of decades or three or however many you want, what is it
Yeah.
that we could be looking at? Are we still looking at these sort of hybrid transfer learning type approaches, or are we looking at some sort of radically new paradigm that would marry these things together? Hybrid AI fashion with like some completely systematic new paradigm.
I think it's a good question. It is something that I think about a lot, and big disclaimer obviously is that the further away we get from today, the less certain I can have any kind of confidence. I do think that a couple of things that are certainly going to be true is I think that the way that we think about training models today, that absolutely is like not sustainable, and that has to change. Right. Today, we think very much we're training things up from scratch, right? Transfer learning, to your point, it's getting much more common, right? But it's still not the way that you train most things. And while we're going to continue making incremental computational improvements, that's really where, there's no shocking breakthrough we're going to hit there. And so what that means, I think, is that as we build larger and larger and more sophisticated models, we're going to kind of do away with this notion of training models from scratch because it's just so impractical.
This is what's
And
called
there's a
zero
notion
shot
that
learning, right?
it's a part of that,
Yeah.
right? I mean, the way that you tackle zero shot learning, I think that's a great place to look for kind of early research that's pushing along in this path, right? And I think another really great thing to look up is this concept of model surgery by OpenAI. And again, it is this notion that you're going to be chaining models together. You're going to have, a base model that has been trained on, bajillion data sets, and then you're going to be making tweaks and tweaks and tweaks, and there will be model lineages and, questions much more along those lines. So I think that's one aspect of what is going to change. And I think, and, there is a discontinuity coming up, right? And I don't know that I would call this an AI winter, but certainly there are people who have pitched far beyond AI's ability to deliver. And I think we have a good sense of what is possible in the current deep learning JAG. I personally very much don't believe that this current approach is going to solve all of our problems. I think that we've got an infinite number of problems, and I do think that this is going to get us very, very far. Call it 1 to 2 decades, and then what is going to have to advance for us to get beyond our current paradigm, though, I think is compute fundamentally. And right now, quantum computing is the most likely contender for something to have a real impact there. But
Right.
to throw out maybe an underdog, there's new memory technologies as well that could have a similarly massive impact on what the future of compute looks like. So maybe
But
something else
what's
there gives us potential.
what sort of magnitude improvement would we need, do you think, in the compute? Because quantum, famously is a quantum leap. Certainly, we're talking thousands and 10,000s and maybe
Yeah.
much more than that in terms of kind of effectiveness improvements. What sort of leap do you think would make a fundamental change that would change the ball game, whether you started from zero or from previous models?
So, I mean, I think very much in orders of magnitude. I think that's how I'm not a business person. It's like a 2x is nothing to me. I'm like, what is that? That's a rounding error, right? So, no, I think that GPUs are a great historic benchmark, right? GPUs, I think, commercially accessible and available, individual GPUs led to this last renaissance. And that was, somewhere around a 40x practical improvement in runtime. Right? Maybe a little north of that, depending on how you did it. But I actually think it's going to happen very much the same way, because the thing is that we changed our technique. GPUs empowered the first leap, and then we started to change our techniques to match GPUs such that we could push those multiples higher and higher and higher. I think exactly the same thing is going to happen, because most of the things that we do today in AI, they don't have obvious quantum improvements. It's not to say we won't find them. Obviously, it's a very far future path. I can't make any assertions about them, but I think it's drastically more likely that we are going to find interesting approximations of the ways that we're doing this that are better fit to whatever quantum architecture we end up developing. And in doing so, there are some classes of problems in which, again, if we can hit that 100x, like 2 orders of magnitude, I think that's where you really have potential for a breakthrough. And obviously, more is better, but I think it starts with that.
Towards the end here, a lot of what you do is within the broad category of NLP, which is another sort of famously kind of difficult concept when you really start rounding it up. And it has to do with language and understanding language and human language specifically. Mm-hmm. Arguably, if a machine could render human language and understand human language much, much better by, I guess, to use, your language by orders of magnitude, then that would in and of itself be the kind of progress you're looking for. Mm-hmm. How probable is that? And how much does it really have to do with compute versus to do with really kind of a new mental model for how we translate our own language to a computer?
So I think I'm going to argue that has just happened and has shown a light on the answers to those questions, which, I think in all cases, they're maybe not quite as optimistic as we hoped the first time around. So I'm just going to point to GPT-3, yep. Right? Because from a modeling perspective, the delta between GPT-2 and GPT-3 is minimal, right? Really, GPT-3 is an exercise in scale. And GPT-3 really did, from a compute and data perspective, push the boundary of what we consider possible from a scale perspective. And what GPT showed, which, again, I think it underscores this so much, is that just scaling the method up resulted in drastic improvements. In fact, such that in there's a big but coming, I will say. Such that even in 1 and 2 and 4 shot learning scenarios, just much, much better than humans. However, they also cited the fact that our current problem framings are woefully insufficient to test this language understanding, right? And I think that's really the key to it, is that I think that before I saw really sophisticated language understanding in a sort of brain in a jar type way, I was a lot more excited about it. The more that I realize it, the more that I realize that there's actually no such thing as understanding human language in a vacuum, right? And the second that you give that to someone, they're going to push on edges around like, like it should have opinions about things, right? It should be able to understand some physical reasoning about the outside world. And I think those are all completely valid. But it's also why I say that I think we have pushed language really, really far. I think we've accomplished incredible things there. And I think that our ability to model language far outstrips our ability to ask demanding language problems. And I think that's where this problem is most acutely felt, is that we need better language problems, right? This is where the Clever Hans effect came from, right? Is we need people creating data sets really using this detailed supervision that is linguistic, and also things that really importantly bring language into the broader context, right? Whether that's chat conversations, just understanding the thread, right? Whether that's, Reddit comment threads is, that's something, right? But like anything in that direction, obviously for us, that's bringing positional information in, studying the language of the document and the position of the document. But those are all fringes in that surface area, right? These are all really, I think, powerful areas of exploration.
Slater, just for the benefit of my listeners and myself, GPT, what does it stand for again? And GPT 1, 2, and 3, can you just line up sort of roughly when these things happened and why they're relevant to what we were just talking about within NLP? Because, people have different levels of awareness of all these things, and not everyone sits there and waits 100%. For GPT 3 to be issued.
No, it's very, very fair. So GPT stands for generative pre-training. And it's, GPT 1, 2, and 3, that's a series of models produced by OpenAI that fundamentally all center around this idea of if we feed just a huge amount of text to our model and ask it to kind of predict the text that comes forward and, understand it from a kind of semantic and grammar perspective, that is enough to kind of give us true intelligence, if you will. And so that's kind of the notion of this whole GPT string of papers. Now, the lead author on GPT 1 and 2 and kind of the like father, I guess, of GPT, Alec Radford, he's a close friend and a co-founder of mine, actually. But then maybe another note for folks that might have tracked this part of the news a little bit more. One thing that's really interesting is that, and this is the tragedy of the name GPT. Honestly, it's a terrible name, right? It's super not catchy, right? GPT-3, maybe it rhymes a little bit. Maybe that's why that one got picked up. But GPT-1 and BERT came out at almost exactly the same time. BERT came out just a little bit after GPT-1. And the two papers were so similar that BERT actually had to kind of put a pause on their publishing to add, like 5 paragraphs throughout their paper being like, okay, but here's why it's different from GPT. But again, it was just parallel discovery, right? Is they both hit on this really, really great idea. BERT had, an improvement in some ways. But I think the branding success of GPT-1 versus BERT goes to show just how, really goes to show how much the AI community loves our Muppets. I think maybe that's the lesson of the whole thing.
Well, it reminds me, and I will be mixing metaphors slightly here, but when we had mapped the human genome quite a long time ago right now, some people who weren't in the space and some people who were very much in the space said, it's all over now. We have mapped it. Everything's going to change. And guess what? Decades later, yes, everything has changed because we have mRNA now. We have applied it to vaccines. Everybody has felt it, what this change means, and the synthetic biology field, and many, many, many improvements have happened. But no, they didn't happen overnight, and they required much additional modeling, thinking, creative thought, and you just had to experience time.
No, I think that's exactly right. Just like mapping the genome is very important for us to take a beat. We should recognize, like, yes, we have made progress. This is awesome, right? Like, pat ourselves on the back. But really, the only thing we've done is we've turned over the next card, and we see the next 6 problems that we've got to solve. Right now, suddenly we've got an explainability crisis on our hands. Right, we've got multimodal methods that we need to improve. We need to understand how bronze and gold and silver data come together in the future. Right, we have to understand how we're going to regulate these and make sure we're not selling snake oil. Right, and I'm excited for all of these problems. I think that they show more clearly than anything the fact that we are concerned with these issues, that AI is hitting the mainstream, and these problems are not trivial, but they are solvable.
Slater, we're coming to an end here, but one of the things that I really have come to appreciate about you in the very short time that I have known you is that, you may have started out a prodigy, and prodigies can sort of go several ways, right? It's, you are in a certain sense better than people because you have some thought patterns that are divergent, and arguably, you accelerate faster. But one thing that you haven't done is fallen into the trap of skipping the explanation step. You've been very pedagogical with me and with my listeners, and I find that a very attractive feature in smart people because it's so important. And I find it perhaps one of the most important things these days is that because knowledge arguably is advancing, but you have been so humble about the degrees to which it is also not advancing. And I think to keeping all of those things in mind and bringing us all along for the ride. Yes, it is slower, right? But explainability is important. And it may even be important to
Thank you
your
so much for
colleagues.
saying
No,
that.
and I think it's a great compliment that I wanted to give you. And it's so important. And I think I would even argue that I don't really want the kind of genius that doesn't explain themselves because life is too precious for that. And we may be making progress, but you got to string people along. So thank you for stringing me along, and I wish you all the best in in taking this further in your way. And I hope to have you back on the show some little while ahead when we have new problems to talk about and deconstruct.
Absolutely. Thanks so much for having me. It was a total pleasure. Very happy to do it anytime. And no, I totally agree. The only I'll have one gripe, which is that I don't think that I'm smart. My view is that the whole of knowledge is so large that none of us know anything. Right? We're all kind of running around here. So the least we can do is help each other where we can.
Well, thanks anyway.
Look, total
Yeah.
pleasure. Thanks so much for having me
All
again.
right.